I am going to explain SR action of XR flip-flop. It is related to 2022 A-Level Physics MCQ question number 16. This SR flip-flop. It is used. It is consist of two NOR gates. R and S are two inputs. They can take these values, these four values, and Q and Q bar are two outputs, and Q and Q bar are inverted values. They can take inverted values. Therefore, if Q equals 1, Q bar equals 0. If Q equals 0, Q bar equals 1. And they can't take same values 1 and 1 or 0 and 0. I will check when R equals 0, S equals 0, and R equals 0, Q equals 1, and Q bar equals 1, 0. I took the first memory set. If there was this memory set, then Q bar equals 0, it comes to this point, and R equals 0, Q equals 1. When Q equals 1 comes to this point, S equals 0, therefore Q bar equals 0. Therefore, this result is equal to the previous result. And also I will check for the second memory set. If there was second memory set, Q equals 0 and Q bar equals 1, then Q bar equals 1 comes to this point, and R equals 0, therefore Q equals 0. When Q equals 0 and S equals 0, Q bar becomes 1. This memory, latest memory, also equal to the previous memory. Therefore, these two occasions, the latest memory is equal previous memory. Therefore, this combination of inputs called previous state. Then I will check for second set of input, S equal 1 and R equals 0. And for first previous memory set, Q equal 1 and Q bar equals 0. When Q bar equals 0 goes to this point, and R equals 0, Q should be equal 1. The latest memory, Q equals should be 1. When Q equals 1 comes to this point, and S equal 1, Q bar equals 0. This is also previous memory set, but we have to check for second memory set. Q equals 0, Q bar equals 1, and S equal 1, R equals 0. For Q bar equals 1, it comes to this point, and R equals 0, Q equals 0. And due to Q equals 0, it comes to this point, and S equal 1, therefore Q bar also 0. But I said Q and Q bar can't take same values because these are inverted values. But this result do not remain a long time. The next moment it will be changed. We can check how this result change. Q bar equals 0 comes to this point, and R equals 0, 0, 0. This is Q equals 1. This change to Q equals 1. And due to Q equals 1, it comes to this point, and S equals 1, Q bar becomes 0. You can check these results in inputting this result and the latest result after reaching. That is also same to this result. Therefore, this state is stable state. This any category, any memory category for these two categories, the output is same. Q equals 1 and Q bar equals 0. Q equals 1 and Q bar equals 0. This is called set state of SR flip-flop. Then I will check the third input set, S equals 0, R equals 1 for first memory category. When Q equals 0, it comes to this point and R equals 1, therefore Q equals 0. And Q equals 0 comes to this point and S also 0, therefore Q bar equals 1. This is the latest one. And also I will check also for the second memory category. If there was this second memory category for S equals 0 and R equals 1. Q bar equals 1. Due to Q bar equals 1, it comes to this point and R equals 1, Q equals 0. And Q equals 0 comes to this point and S equals 0, Q bar equals 1. Therefore, for any memory category and S equals 0 and R equals 1, then the final result is Q equals 0 and Q bar equals 1. Same results. Therefore, this result, this input is called the reset state. And the next one, 1 and 1, we don't input 1 and 1, it's not stable state.